This is Sal here with famous IndyCar driver. He's smiling when I said famous. J.R. Hildebrand. And since you're here, I thought I would ask a question that's always been on my mind.
Yeah,
we
sure.
have a picture here of the Indianapolis Motor Speedway.
Yep.
And I've always wondered, how it seems like turning is a very important part of the.
That is absolutely an important part of what we're doing.
Of the race.
People get fixated on the car going straight, but the turning part is pretty
seems
important.
to be where a lot of the skill comes into it. And I've always wondered, what is optimal? Do y'all try to minimize your distance and kind of take the turn as quickly as in as short of a distance as possible by kind of really hugging the corner by going like that? But when you do that, you have to turn more. There's more G forces. There's more kind of centripetal force that your tires have to deal with, that the human has to deal with, versus taking the outside where you have to cover more distance, but the centripetal acceleration, the G forces aren't going to be as dramatic. So how do you think about that?
Well, every track ends up being a little bit different. But when we take Indianapolis here as the example, if you're all the way on the inside, it's like the 800-meter runner's kind of path. It's the shortest distance. You can kind of get from point A to point B. The lap is the same every time, so it doesn't actually depend on you running a specific distance or not. For us in this example, the car actually just won't do that. If you think about being all the way on the inside, through the corner, and then exiting all the way on the inside, it's having to do the most work to follow that path. And in Indianapolis, we're approaching turn 1 at upwards of 240 miles per hour.
Wow,
and that
okay.
turn 1 is not, it's hardly banked. It looks quite flat in person. So as opposed to, NASCAR running at Talladega or Daytona, these big giant super speedways, the car is having to do quite a lot of work to get through the corner here.
So do you take the outside, or is it?
Well, so then, you look at that, and I think if you noted sort of the radius that we like, if you drew a full circle out of each of those arcs.
Okay, so let's do that. So let's say this is the shortest distance path. This is kind of a circle that looks something like my best. Let me scroll over a little bit so that we can see it a little bit better. So this would be a circle like this. If you were to keep that arc going, it would be a circle that looks something like this. And
so that's a pretty small circle.
It's a small
in the big scheme of things here, yeah.
And for the larger one, the circle would look something like this.
Right.
So you have a larger radius, a larger turning radius, so you would have to have less centripetal acceleration, inward acceleration, and fewer G-forces on this outside one.
Right.
The larger the circle is.
In a different way to look at it, if you looked at the car trying to just go around these two different circles, and it's going to be going the same speed on either one, it's doing a lot less work to get around this outside circle. And therefore, the speed that you could carry around that then sort of goes up. The car has a limited ability to stick to the racetrack. So I think opening that up definitely makes a big difference.
But that's an important point. At least in Indianapolis, you're full throttle the entire way.
Yeah,
so when you're saying, obviously if you hit the brakes, the car could do what a very small turning radius. That's a good point. Yeah. But you're full throttle. You're not going to have any chance if you at all let off the gas.
That's right. When you qualify at Indianapolis, you've got to put in 4 of your best laps of the season of your career in Indianapolis to qualify, and that you are absolutely flat chat the whole way around the racetrack. There's no lifting. There's no braking.
And so that's why you're saying the car just wouldn't do that. If you're going all out, the car just wouldn't even be able to make this path
exactly.
right
So that's a good point. From the driver's perspective, you have to stay flat out if you're going to go fast. If you're going to set a lap time that's relevant, you have to be able to stay flat out. And so at that point, then you're searching for the line around the racetrack that you can do that most efficiently.
Right.
And so then in this example, increasing that radius by going from our green circle out to the purple circle does that rather effectively.
I see. Or going from the purple to the green back to so you're saying like this.
Well, yeah. And so then to find the actual optimal line, what we end up doing is starting out on the outside of the track, then bending the car into the inside of the track, and going back to the outside of the track, really using all of the road that's available to us.
Right. So that's interesting. So, when I posed the question, it was kind of like my brain was just looking at these two circles, but you realize there's a bigger circle that you could fit here, that there's an arc like this, and this would be, if you imagine, this would be a part of a circle that's way huger than even that purple circle that we're drawing.
Yeah.
The turning radius, the center of that circle is like here or something.
Right.
So you have a lot less centripetal acceleration that you have to place, inward acceleration that you have to place on the car.
Exactly. And therefore, the car is able to carry a massively increased level of speed through the corner, and that's really what we're looking for. You consider, I think it's a very interesting, when I think about what I'm doing as the driver, I don't think I really am consciously thinking that much about the mathematics that go into finding this optimal racing line. You sort of instinctually just gravitate towards what the car feels like it wants to do.
Right.
But when we look at it from this perspective, you've got the car going down the straightaway here. It's at 240 miles per hour. That's almost as fast as the car is going to go. So it's just this sort of terminal velocity. The drag of the air hitting the car won't allow it to go much faster.
The engine's giving all the power it can.
Yeah, you're absolutely
and that's
flat
just
out
offsetting the drag of the, so you can't accelerate.
Exactly. It's almost like you're hitting a
Top
wall
speed,
of air
right,
at that point.
right.
You're not going to be able to accelerate any faster. And so what you're really trying to do is you're trying to, in order to set that fastest lap time, which ends up equating to the highest average speed around the lap. That's what's the lowest number in terms of a lap time perspective. You're trying to get the car to most efficiently get through the corners so that you can allow it to accelerate down the straights as much as you can. You're sort of getting it to diverge from this intended course that it's going on here as efficiently as you can. And so by creating the largest radius around the corner, that's how we end up finding that optimal line.
That's fascinating.